This is our very last video, and we want to talk about the binomial theorem and what we call binomial expansion. So I want to be able to expand something like down here, 2x plus 5y to the third, using this formula. I know this is a scary looking formula. Listen, if you ever see this summation notation, so I'm going to highlight that for you, this part right here, okay, highlighted in yellow, that means add up all of these things. So the good news is it's written down below here. I don't know, that might not look any better, but that's what that means, all added together. So notice the formula says the first one doesn't have a coefficient. You could do n choose 0. We talked about that in the last video. And something else I want to point out, if this doesn't make any sense to you, what that means, that n choose k in parentheses like that, you need to go back and watch the last video, because we covered a lot about what all of this means and the patterns involved, and what we're going to do in this video are complete problems. Okay, so if this looks foreign to you, or I start working this problem and it's like, what in the world is she talking about, please go back and watch the last video, because it's an introduction into all of this notation. Alright, now we're following a pattern. So remember the pattern from the last video. The first thing you do is you could do one of those, you could do n choose 0. Okay, or you can just do, like they have here, is a 1. We'll do it that way, the way it's written here. Alright, so it's x to the n. Now, our problem, n is 3. We maybe need to write that down, because that comes from this exponent. Okay, so our answer, 2x plus 5y to the third, begins with the first term, not just x to the third power, but this whole thing. So it's going to be 2x to the third plus, now there's our binomial coefficient. You can use Pascal's triangle if you want to, but we're going to use the coefficients as it says. So it's n choose 1, our n is 3, so it's 3 choose 1, and then it says x to the n minus 1. This is where we start going down with our exponents. X means the first one, so this is x right here, and this is 5y to the third. So it's going to be 2x squared. Remember, it started with 2x to the third, and then times y, so it's going to be times the second one. My computer's not doing right. 5y to the first. Okay, so you start counting down on your first term. So it went 2x to the third, 2x squared, and you start counting up on your second term. This is 5y to the 0, so I didn't put it there, 5y to the first. Then you move on to your next binomial coefficient, which is going to be 3 choose 2. And then you count down on your first term, so if that's to the second, now it's to the first. And you count up on your second term, so 5y squared. And then finally, our last term is going to be 3 choose 3. And we have 2x to the 0, so it's not really there, and 5y to the third. So I want you to watch this. The first term started at the highest exponent and is counting down. So I'm going to highlight those in yellow. So 2x to the third, and then went to 2x squared, and then it went to 2x to the first, and then went to 2x to the 0. Look, the y values start counting up. So this is like my second term to the 0, my second term to the first, my second term squared, my second term to the third. And then you have the coefficients in front. And you could have a 3 choose 0 here, which is just 1, so we can leave it off. Then 3 choose 1, 3 choose 2, 3 choose 3. And that's it, completely filled out. The remainder of the work is simplifying your expression. Okay, we can do that. 2x to the third, you got to raise both of them to the third, because this is multiplication. So 2 to the third is 2 times 2 times 2 is 8. And then I have x to the third. Plus 3 choose 1. Remember the formula. That's 3 factorial over 1 factorial, and then subtract them, 2 factorial. We'll finish it out in just a minute. 2x squared is 2 squared times x squared, which is 4x squared. 5y to the first is times 5y. All right, you hanging with me? Plus, then we have 3 choose 2, which means 3 factorial over 2 factorial, and then you subtract the 2 times 1 factorial. And then 2x to the first is times 2x. Now, 5y squared means all of that squared. The 5 is squared, so that's 25. The y is squared, so y squared. Then my last term down here is 3 choose 3. So that's 3 factorial over 3 factorial times 0 factorial. Notice they didn't even put that. They just put times y to the end. So that's just going to be 1. We'll see that in a minute. This is gone. 2x to the 0 is just 1, so I'm not going to even write it. You can omit it. Times 5 to the third is 125. Y to the third is y to the third. And now we continue to simplify. So this is 8x to the third plus, now this 3 factorial over 2 factorial is 3 times 2 factorial over 2 factorial, because 1 factorial is 1. Those cancel, that's just 3 that's left. Times, now 4 times 5 is 20. X squared times y is x squared y. Plus, now 3 factorial over 2 factorial times 1 factorial. Again, you could write that as 3 times 2 factorial over 2 factorial times 1 factorial. Those 2's cancel. Again, if that doesn't look familiar to you, go back and watch the last video. Now, 2 times 25 is 50, and that's x y squared. Plus, now this is 1 because those cancel. My computer is doing awfully. That's 1 times 125y to the third. Now, we're still not finished, okay? We must simplify completely. At the top of the page, I'm going to write our final answer because I still have to multiply. The 8x to the third is completely simplified. That is going to be 8x to the third plus, now my next term has 3 times 20 times x squared y. So that's 60x squared y plus 3 times 50 is 150 xy squared plus 125 y to the third. And that is my final answer. Alright, so here I would like to try another problem. I had the formula written here, but it just takes up so much space, so I'm going to leave that off. So remember what we do for our first term, I'm just going to put equals here, is we take, this is our first and this is our second. Okay? Now, there's the first coefficient is a 1. If you think about Pascal's triangle or you think about 3, choose 0, that's 1. Then you start counting down with the exponents. So the first one to the third, and the second one you don't include at all, or to the 0. I'll go ahead and put negative 3y to the 0. So the first term goes at 3, whatever that is, and the second term goes to 0, and you take the sign with it. And then you do plus, always plus. Now our exponent is 3, so it's 3, choose 1, okay? And then your first term is negative x, but you're counting down. So if that's 3, the next one's 2. And then your y value, negative 3y, is counting up. That's 0, so that's at 1. Plus, then you have 3, choose 2. So notice I'm counting up on my bottom numbers. Times the first term, negative x, it's counting up. So it's to the third. It's counting down, sorry, to the first. So it's 3, then 2, then 1. And then my second term, negative 3y, is counting up on the exponents. It's a 1, now it's a 2. And then my last one in line, you could either put 3, choose 3, or you can just put that 1, because the first one and the last ones are always 1. Negative x to the 0 power, because it's counting down. Notice 3, 2, 1, 0. And then my second term, negative 3y, is to the third. So again, I want you to notice the patterns here. Okay, so the coefficients are 1, 3 choose 1, 3 choose 2. You could call that 3 choose 3, which is 1. And then my y pattern, okay, my x pattern, negative x to the third, negative x squared, negative x to the first, negative x to the 0. So you have they're counting down, 3, 2, 1, 0. And then finally, my negative 3y, my second term, counts up. It starts with 0, and then it goes to the first, goes to the second, goes to the third. Okay, so it looks super complicated, but it's not really once you figure out the pattern. Now, what we're charged with now is simplifying. And this may be where you miss the homework because you just accidentally simplify something wrong. Now, this is 1 times something, so I'm not going to write the 1 anymore. Negative to the third power is a negative. X to the third power is x to the third. Anything to the 0 is just 1. So I'm going to put times 1 just for your notes, but it's just 1. 3 choose 1 is 3 factorial over 1 factorial, and then you subtract the 2 times 2 factorial. Negative x squared is x squared. A negative times a negative is a positive, and then x squared is x squared times negative 3y, because it's to the first. 3 choose 2 is 3 factorial over 2 factorial times 1 factorial. Negative x to the first is times negative x. Negative 3y squared, careful here, negative 3 squared is 9. Y squared is y squared. Okay? Plus, now, anything to the 0 is 1 times 1, so that's still 1. And we raise negative 3 to the third, which is actually negative 27. And y to the third is y to the third. Now we're closer. We just need to simplify a little more. First term, negative x to the third times 1 is negative x to the third. We need to calculate this coefficient, or you can think about it as Pascal's triangle. Remember, Pascal's triangle says 1 and then 1, 1, then 1, 2, 1. Now that's row 3, which applies to x squared, or 1, 3, 3, 1. This is the row that we need to be using. So there's our 1. That means this is going to equal 3 if we calculate it, and it is, because, let me do this in red, this is 3 factorial. Oh, I'm sorry. I've already done that part. That's 3 times the highest in the denominator is 2 factorial over 1 factorial, which is just 1, times 2 factorial. Those cancel, and there's your 3 right there. Okay? I keep simplifying. This x squared I'm recopying as x squared times negative 3y. We'll multiply all that out next go around. Plus, now Pascal's triangle says the next coefficient is 3, or we could crunch those numbers. 3 factorial over 2 factorial times 1 factorial is 3 times 2 factorial over 2 factorial times 1 factorial. The 2 factorials cancel. 3 divided by 1 factorial, which is 1, is 3. So that's 3 times negative x times 9y squared. And then this is simplified, minus 27y to the third. We've got one more line to do. So it's negative x to the third. This 3 times this negative 3 is negative 9x squared y. 3 times a negative is a negative 3 times 9 is negative 27xy squared minus 27y to the third. And that is completely expanded using the binomial theorem. You could multiply that out 3 times. It might take just as long. But when you get to fourths and fifths, and even sixths and higher, you definitely want to use this formula. Definitely. All right, so I have 2 more problems. I want to break this down as well as I can. So the first thing I want you to think about here is it's to the 4th power, which means we have 5 terms. Remember, you always have one more term. So let's do the coefficients first. Let's do everything one at a time. So I'm going to have 5 terms I'm adding together, okay? So the first coefficient, remember, is 1. It's always a 1 to start with. So I'm going to put 1 for our first coefficient. And I'm going to leave us some space, and our next term, our coefficient, is 4 choose 1. Then leave some space. Our next term is 4 choose 2. Our next term is 4 choose 3. And our last one, I didn't leave myself enough space, is 4, choose 4. We might have to get kind of tight over here, squeezing everything together. Oh, by the way, 4, choose 4 is just 1. So if you want to say the first one, the last one is 1, that's okay. So 1, 4, choose 1, 4, choose 3, 4, choose 2, 4, choose 3, 4, choose 4, but 4, choose 4 is 1. Just like this is 4, choose 0. Now I want to take a look at, in a different color, let's do our first term. So we're going to have 3x, and you always start with the exponent to the 4th. Then you're going to have 3x to the 3rd. Then you're going to have 3x squared. Then you're going to have 3x to the 1st. And here you're going to have 3x to the 0. See how I did that? 3x is my first term in my binomial. And I raise it to the 4th, which you start at the exponent power. And then 3, then 2, then 1, then constant. There's 0, which is a constant. Okay? Now let's look at our y powers. So we'll do this, and again in a different color. I'm looking at negative 2y. You got to take the sign with it. So this is going to be negative 2y to the 0. Then count up. Negative 2y to the 1st. Negative 2y to the 2nd. Negative 2y to the 3rd. Forgive me for space. Negative 2y to the 4th. See how we did that? So if you want to, think about your coefficients separately. It starts with 1, and then you have the exponent, choose 1, the exponent, choose 2, exponent, choose 3, exponent, choose 4, or it ends with 1. Then look at your first term. The whole thing raised to the exponent, and then start counting down. 3x to the 4th, 3x to the 3rd, 3x squared, 3x to the 3rd, 3x to the 0. Then you look at your second term, negative 2y, and it counts up. So at the first expansion, the first term of expanding, it's to the 0, then negative 2y to the 1st, negative 2y squared, negative 2y to the 3rd, and negative 2y to the 4th. Then after that, it's just a bunch of number crunching. Okay? So the 1 I'm not going to write, because 1 times anything is itself. You've got 3 to the 4th. Now 3 to the 4th, you know, is 3 times 3 is 9 times 3 is 27 times 3 more is 81. Now negative 2y to the 0 is just 1. Anything to the 0 is 1. Okay? Plus, now I've got some crunching to do here. 4 choose 1 is 4 factorial over 1 factorial, subtract them, times 3 factorial. We'll simplify it more in a minute. 3 to the 3rd is 27. X to the 3rd is x to the 3rd. Negative 2y to the 1st is just negative 2y. Plus 4 choose 2. That's 4 factorial over 2 factorial, and then subtract them times another 2 factorial. Then I do 3x all squared, so that means 3 squared is 9, times x squared is x squared. Negative 2y squared, negative 2 squared is 4, and y squared is y squared. Plus, this expansion, this coefficient is going to be 4 factorial over 3 factorial times subtract the 2, 1 factorial. We'll simplify that in a minute. 3x to the 1st is times 3x. Negative 2y to the 3rd, be careful here. Negative 2 to the 3rd is negative 8, and y to the 3rd is y to the 3rd. Okay, there's a plus in there. It's hidden underneath my red writing. 1 times 3x to the 0. Anything to the 0 is 1. So all this is 1 times negative 2 to the 4th. Now, negative 2 to the 4th power is negative 2 times negative 2, which is 4, times negative 2, which is negative 8, times negative 2, which is positive 16, y to the 4th. Believe it or not, we're almost there. Okay? Now, here, I left off my x to the 4th. I just noticed it. You probably noticed it a long time ago, and it's been killing you. That's 3 to the 4th times x to the 4th. I just didn't write down the x to the 4th. So my first term, when I multiply this out, is 81x to the 4th. Plus. Now, let's simplify this. 4 factorial, I can write that as 4 times 3 factorial, right? And this 3 factorial cancels with this 3 factorial. That's just really 4 divided by 1, which is 4. So that's 4 times 27x to the 3rd times negative 2y. We'll multiply all that out in a minute. Plus, now here we go again. I'm going to do this right on top of it. 4 factorial divided by these 2. That's 4 times 3 times 2 factorial. This 2 factorial cancels with that one. That's 4 times 3 is 12 divided by 2 times 1, which is 6. Or you could use your Pascal triangle like we learned in the last video. That's 6 times 9x squared times 4y squared. We'll multiply that out in a minute. Plus, here we go with this 4 factorial over 3 factorial times 1 factorial. That is just 4, but let me show you why. Because I can write 4 factorial as 4 times 3 factorial. These 3's cancel. And then 4 divided by 1 is 4. Times 3x times negative 8y to the third. I didn't mean for that to be green. There's nothing special about it. Okay? Plus 16y to the fourth. Now, one more row and we'll be finished. I've got 81x to the fourth plus, now actually it's going to be minus, right? Because I have positive times negative, and I definitely need my calculator for this. I don't want to crunch those numbers. 4 times 27 times negative 2 gives me negative 216. So this is minus 216, and check out my variables. I got an x to the third and a y to the first. Now this is going to be positive because all that's positive. 6 times 9 times 4 is another 216, and that's going to be x squared, y squared. Okay, so 6 times 9 times 4 is 216, and then x squared times y squared. Okay, now this is going to be a minus. Okay, now I've got 4 times 3 is 12 times 8 is 96. I almost said that wrong. And then that's x to the first, y to the third, plus, and the last one already simplified, 16y to the fourth. And that is completely simplified. Now, I know that might seem horrible, but it's better than multiplying 3x minus 2y out 4 times. That would take up all of this page and probably then some. Okay. Now, I've got another one because I feel like you need to see one more because I know this can get confusing. And this problem is a big one, right? It's to the fifth. I worry about how much space I'm going to have to get it done, but I'm going to try to write a little smaller, maybe a little slower so it's neater. But now, here we go. Remember, your first coefficient is 1, no matter what. Okay? And then, what do? You multiply that, and we'll try to do this in different colors. My first term is 4x, and that is 4x to the fifth power from there. Times the second coefficient, or the second term is negative 3y to the 0 power. So what happens is the first term exponents start to count down, and the second term exponents start to count up. So you count down from 5, because that's the exponent, and you count up from 0. So let's move on to the next coefficient. So that's going to be plus. I'm going to use that combination notation. So it's going to be 5 choose 1. Okay, the 5 comes from the exponent, and the 1 comes from, this is really 5 choose 0, which is 1. So it's counting up. Now my first term is going to be 4x to the fourth now, because it was fifth first, now it's fourth. And then my second term is going to be negative 3y to the first. Okay, so I have another plus, and now my next binomial coefficient, which is going to be 5 choose 2. It's always 5 on the top from the exponent, and what you choose rises as we go along. Okay, now what's my first term going to be raised to? 4x to the what? Notice it's counting down, so 5, 4, this is going to be to the third. And my second term, negative 3y, is counting up, 0, 1, 2. Plus, my next binomial coefficient is going to be 5 choose 3. Okay? And then my first term, the exponent is going to be, it's counting down, remember? So it's 5, 4, 3. Now this is a 2. On the other hand, my second term, the negative 3y, is counting up. So 0, 1, 2, this is to the third. Plus, my next coefficient is going to be 5 choose 4, right? My x's or my first term is counting downward, 5, 4, 3, 2, 1. Whereas my second term is counting up, 0, 1, 2, 3, negative 3y to the fourth. Now here's the problem. I don't have enough space on this line, so I'm going to come right underneath here. Plus, remember our last coefficient is 1, or you could say 5, choose 5. Both of those are correct. Now the 4x is counting down. Remember, 5, 4, 3, 2, 1. This is 0, which really means that's 1. It's not there at all. And then what's happening to my second term, my negative 3y, is counting upwards. So that's to the fifth. So again, check the pattern. It's all about the pattern. Okay, so notice my coefficients are 5, choose 5, which is 1. 5, choose 0, which is 1. 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4. This is 5, choose 5, which is also 1. So you start with a 1 and you end with a 1. The first term exponents count down, 5, 4, 3, 2, 1, 0. The second term, you have to take the sign with it, so that's negative 3y, not just 3y, counts up. So 0, 1, 2, 3, 4, 5. Now it's simplifying all the way. I'm going to do that in blue. So 1, I'm going to leave off. 4 to the fifth. Now what is 4 to the fifth? It's pretty big. 4 to the fifth. I got 1024. So that's 1024. You also have to do x to the fifth. Now negative 3y to the 0 is just 1. That's completely gone. Plus, now 5 choose 1, calculation-wise, is 5 factorial over 1 factorial times 4 factorial, which, folks, that's just 5. You do enough of these, you'll figure that out. We'll write that down in a minute, though. Now, 4 to the fourth is 4 times 4, which is 16, times 4, which is 64, times 4 more is 256. I should know that really, but at the moment I couldn't remember. So that's 256 x to the fourth times this negative 3y to the first. I'm just going to put in parentheses, which is negative 3y. Plus, here we go, 5 choose 2 now. That's 5 factorial over 2 factorial, and then you subtract them times 3 factorial. We'll simplify it in a minute. 4 to the third, we know 4 times 4 is 16 times 4 is 64. X to the third, I'm on the green now, negative 3 squared is 9y squared. Plus, I'm going to simplify this 5 choose 3, which is 5 factorial over 3 factorial times 2 factorial. 4x all squared. 4 squared is 16x squared. Negative 3 to the third is negative 27y to the third. Now, this is starting looking messy. I am right here at this point. Okay? So I'm going to put plus. And I need a line here to separate what the world. Okay. 5 choose 4 is just 5. But we'll figure it out. 5 factorial over 4 factorial times 1 factorial. 4x to the first is times 4x. Negative 3y to the fourth. Now that gets big. Negative 3 to the fourth is positive 81 y to the fourth. Okay. Plus, this is my fifth term. 1 times, this is 1 times negative 3y to the fifth. Okay, now negative 3 to the fifth we know is negative, right? So it's going to be a minus. 3 to the fifth is 243, so minus 243 y to the fifth. Again, now if you need to pause it and start working this out on your own or back up, I do encourage it. It seems like it's hard what I'm doing here because you might lose track of the calculations, but you can do all of this. I know you can. It's just as easy to get lost in me doing it via a video. But I'm going to keep going, but pause it, catch up with me, make sure we're right. And I might even have an error, so let me know if you notice in the videos that I do. Alright, here we go. First term is completely simplified. I'm happy with that. 1024x to the fifth. It's done. Now, this 5 factorial over 4 factorial, Let's simplify that underneath, or better yet, 5 factorial, I'm going to rewrite as 5 times 4 factorial. Those 4 factorials cancel, and 5 divided by 1 is 5. Okay, so that's 5 times 256x to the 4th times negative 3y. We'll simplify that more in a minute. That's a y. All right, now let's work on this factorial right here. 5 factorial I'm going to write as 5 times 4 times 3 factorial. The 3 factorials cancel. So 5 times 4 is 20 divided by 2 is 10. So that binomial coefficient is 10. So plus 10 times 64x to the 3rd times 9y squared. Plus, I'm going to work on this factorial. 5 factorial. And the highest on the bottom is 3. So I'm going to write this as 5 times 4 times 3 factorial. The 3 factorials cancel. 5 times 4 is 20 divided by 2 is 10. We got another 10. Now if you consult from the last video, Pascal's triangle, we know that's 10 times 16x squared times negative 27y to the 3rd. We'll multiply all that mess out in a minute. Right here, 5 factorial over 4 factorial times 1. I can write that 5 factorial as 5 times 4 factorial and cancel those 4 factorials, which is 5 divided by 1, which is just 5. So that's going to be plus 5, and then you still have times 4x from here times 81y to the 4th there. Finally, minus, I'm still going to write it underneath, this last term right here, I'm trying to keep these lines separated, 243y to the 5th. It's huge, but I'm about to write our final answer. And I'm going to do it in black. Make it official. So my first term is 1024x to the 5th. Now I'm going to multiply 5 times 256 times negative 3. We know it's going to be negative. It's big. 5 times 256 times 3. Negative is negative 3,840. And that's x to the 4th, y to the 1st. You agree? Let's check it again. 5 times 256 times negative 3 is negative 3,840. And then notice I have an x to the 4th and a y to the 1st. So we're good. Now here again I'm multiplying 10 times 64 times 9. Which is 5,760. It's positive. Okay, x to the 3rd. Y squared, plus I'm multiplying 10 times 16 times negative 27. That's not positive, that's negative, so I should have put minus. Now 10 times 16 times 27 is minus 4,320. Look at my exponents. I got an x squared and a y to the 3rd. Now plus, hey, you notice how the signs alternate? It was positive, then negative, then positive, then negative, then positive. That's going to happen when you have a minus in your binomial. They're going to alternate like that. Okay, so where was I? I did 10 times 16 times 27. Okay, now I'm over here at 5 times 4 times 81. 5 times 4 times 81. It is going to be a plus. So 5 times 4 times 81 is 1,620. Let's look at our exponents. It's x to the 1st. And y to the 4th, minus, now we'd already had that one, 243y to the 5th. And there we go. How lovely is this? Okay, now, if you think about it, this could feel awful. But I promise you, I promise you, this is better than multiplying 4x minus 3y out 5 times. Can you imagine? It seems like it's easier. I know it probably seems like it's easier what I'm writing right now, but you know it's not. And think about it. You're going to get numbers like this. It's a lot of work, and it's easy to make a mistake. I know it's easy to make a mistake here too, but this is an awesome theorem to save a huge amount of time if by chance you need to expand a binomial. And these neat coefficients that we have in red, they're also called combinations. If you ever take a probability and statistics class, you will see them again. And they're used for something entirely different. it's a counting process, okay, and it's really neat problems as well. So listen, if you notice an error in this, please don't hesitate to let me know in other videos as well, because it's so easy with all this number crunching to make a mistake, and I do want to fix it, but I also want to post these as quickly as I can for you so you have them when you need them. So I hope you have a wonderful day, and that's it, and that's the class. Y'all take care.